Good morning, grade 7. Today we will speak about the second lesson of this chapter, chapter 4, which is patterns and linear functions. We will speak about patterns, which is, I'm sure that most of you have heard about this word. We will look for, how is the sequences of some numbers and shapes. How is it looks like, and we will find out when we can decide that we have linear functions. But first, let's remember together what we have said about dependent and independent variable. Now, a dependent variable, it's a variable that depends upon the value of another. It means that if a value, its value is changing or it's changeable according to other value, okay? While independent variable, from its name, from this, from its character or adjective, which is independent, it means that a variable that is not dependent, okay? We have said that in xy axis or variables or values, actually values of x is independent variable. Okay, so it has its own character, okay, and it cannot be changed or affected by other values. Why actually changing it will change another values, okay, which is, I call it, or another variable, which I call it independent or dependent variable, which is always y. Now, remember that input is the values that is independent, the values of the independent variable, okay? So the input are the values or is the values of the independent variable, and the output is the values of the dependent variables. Now, if you remember, we spoke about it when we graph, when we sketch a graph, and we spoke about the tables. Now, the column to the left is the x, is the x values, which is the independent variable, which actually we call it an input, and the output is the y variable or the values of the y variable, which is actually dependent, variable. Okay. Now, let's define together the function. What's a function? Which is actually, we can use abbreviation like fx for it. Actually, a function is a relationship that pairs one input to exactly one output. Now, if you look at the coordinate of this point, x, y, now for different x, okay, now this tells you the function, it tells you that there must be exactly one output, exactly one value of y for x. So could x be different? Yes, but actually you should know that y must be only one exactly value or one exactly output, okay? Now, when we go to the problems and the examples, we will explain this idea more, okay? Now, a linear function is a function whose graph is non-vertical line or part of a non-vertical line. So, linear function is actually, it's non-vertical line, okay? The graph, you will not see a non-vertical line or part of non-vertical line, okay? Now, the objective of this lesson, which is on page 240, actually it's on page 240, is to identify and represent patterns that describe linear functions. So we will look for only patterns that describes linear function. So we will have actually, let's say, a sequence or a rule for finding linear function. I will explain it and see what will be your rule to decide if this pattern represents actually linear function or not, okay? But first, let's say that in math, we use tables, we use words, we use equations, and sometimes set of ordered pairs and graphs to represent a relationship between two variables. You need to explain the function. We can use the tables, the word, and the equations, okay? Now, this can be done when we are represented with the following: geometric relationships and linear functions, okay? Now, geometric, when we say geometric, we are talking about shapes. Okay, and how we will find out a pattern during the shapes, okay? Linear functions, actually it has a rule. We will find out if there is linear functions or not. In this lesson, we will speak about the geometric relationships and we will speak about linear functions, okay? Let's first talk about the geometrical relationships. Now, we can use words, or we can use an equation, or you can use a table or a graph, okay? We can use these words parts or these words descriptions to represent the relationship between the number of rectangles and the perimeter of the figure. For example, if we go to problem 1, okay? So, if you want to find out what's the function, it means what's the relationship between, the number of the rectangles and the perimeter, okay, of every figure, actually you are looking for a function. If you look for the number of the width and the length, okay, the width and the length of one rectangle, if you look at it as the x, okay, which is actually the input, and you will look for the output, which is the perimeter, okay? Actually, we are looking for what? We are looking for pattern between them, or we are looking for description between them using words, equation, table, and graph. We will use these four parts and we will see how, okay? Just I want you to know that we are looking for a relationship between the same figure. How to find out a relationship between x and y in the same figure. We will now decide x will be what, for example, in the rectangle, and y will be what. Look here. Now, if you look at the figures, I will go back and I want you to look here in problem 1 in front of you in your book. Now, if you look in the first rectangle, okay, now the width of this rectangle is 1 and actually the length of it is 6. Now if you want to find out the perimeter, what you will do actually, you will let's say add 1, okay, to another one here, because you know what's perimeter? Perimeter is the sum of all of the dimensions or the sides of this rectangle. You have here 1, the width of this rectangle, and there is another one facing it here, and when you have the length is 6, you have another length which is 6 here. If you want to find the perimeter, actually you have to add all of the sides of this rectangle together. So you will add 6 plus 1, which is 7, plus 6, which is 13, plus 1, which is 14. This is the perimeter of the first rectangle. How did we find it? Actually, we add all of the length of the sides of this perimeter, okay? So, as you can see here, now first, as we said, we have 4 parts to describe this pattern, okay? First of all, I will use the equation. If you look at the figure, you must realize that the only thing that is changing is the number of the short side, the width. Now looking here, let's go back and look at the figure. If you look here, look, actually 6 is, we can say about it, it's constant. Okay, because actually 6 and another 6 in the other side, so 12 is constant. The length of the perimeter, the length of the rectangles is not changing. It's the same, it's constant. Okay, but actually looking at the width, you can notice as you add more rectangles, you will the width of the new rectangle, which is the big one, actually will be different, right? So changing here will be in the width, not in the length. Now, as you can see here, as we said, that if I'm looking for a relationship between x, which x is actually the number of the rectangles, okay, number of the rectangles in every shape, and we are looking for the y, the output, which is fx actually, and it is how can we find out and function? It means looking for the relationship between the width, okay, and the number of the rectangle. We can notice that the relationship, it's clearly appear that in every time, in every rectangle, يعني you add more rectangle, you multiply it by 2, and you add 12, you will get the perimeter of the new rectangle. How is that? Why we didn't change 12? Because actually 12 is constant. It's not changing. Sorry, the length of the perimeters is not changing. The length, okay, of the rectangles, actually it's not changing. How is that? Actually we have only 6. You can see in your book the shapes that 6 is repeated. I have only 6 and 6, which is 12. I'm looking for the perimeter again, and I'm telling, as I told you, a perimeter is the sum of all of the sides, the length of the sides of the rectangle. Now, the length of this side, the long side, is constant. It's fixed. It's not changing, which is 12. This is why I put it as a number, as a constant. Sorry. While actually, if you look at x actually is the number of the triangle. Now let's go back. In the first triangle, you add 1 plus 1, the width and the other width, which is 2. Okay, so it's 2 times 1, because actually 1 is the first triangle, which is 2. Okay, now in the second, look here, it's the second rectangle. If you can see here, in the second rectangle, I have 2 rectangles, so I have 1 and 1. So I have 2 in the width of this rectangle becomes 2. Now 2 times the number of the rectangles here, which is 2, is equal 4. And actually 4 is the width, the sum of the width of these 2 rectangles. 1 plus 1, sorry, 4, 2, and here 2, it's 4. Now look again at the third rectangle, the third shape, which has 3 rectangles, okay? You can notice that the shape, the length of this rectangle, the big one, is actually fixed, which is 6 plus 6, because we are looking for the perimeter, it's 12, so it's fixed. So it's fixed. Now, while here, since I'm talking about the third shape, which has 3 rectangles, so 1 is repeated 3 times. So I can multiply, the number of the rectangles, which is 3 times 2. Why 2, not 1? Because actually I'm talking about 2 sides, 2 widths. Okay, width here and width here, right? So I'm talking about 2 and I multiply it by 3. Why 3? Because I have 3 rectangles, and when I multiply 3 by 2, which is 6 plus 12, it's 18. It's the perimeter of the third rectangle or the third shape, which has 3 rectangles. And here, etc. I want you now to explain it by yourself and find out the perimeter of this shape, which has 4 rectangles. Now finding the perimeter, it means y, the output. Okay? Now, I hope you understand, and if you want, we will repeat it when we start, solving together from the book, because this example actually it's from the book itself. Okay. Now, what about a table? Okay. Now, as I said, if you want to represent it, okay, so you have to use 4 methods. One of them is the equation, then the table, then the shapes and the graph. Okay, now I will go and explain it more in the other video, talking about the table and then the graph. Okay? يلا, I will finish it here and let's go to the second video.